All right, we're going to take a look at some functions here, or potential functions, and talk about how to determine the domain and range. So I'm going to start by looking at this little guy right here. This is what looks like a little cubic function. And they want us to give the domain and range for it. And the domain is the domain is the set of all x values that can potentially go into the function. So when we have a graph, we're thinking about this thing visually and how it grows, kind of as it moves towards the left and towards the right. Hopefully spanning the entirety of the x-axis. So this little arrow down here and this little arrow up here are really important. That arrow indicates that this is going down and left. And for the domain, it's the and left that matters. It's going in this direction that matters. This arrow indicates that it's going up and right. And again, it's the and right that matters, because as this function grows, as this curve grows and moves to the right, it will hit basically every value on the x-axis, meaning I can go to any coordinate, any point along this curve, and at some point, I can have any value of x exist on this curve. Because it's growing forever to the right, forever to the left, there are no breaks in here. It's going to hit every single x value, which means this has a full and complete domain. The domain is that x is all real numbers. It means it hits every single possible number. And I can write that as a statement, or I can potentially use some notation. That in purple means the same thing. X is in the set of real numbers. This is a capital R with two lines. This is kind of like a little C with a little line through it. And it's just the notation for is in the set of, or is an element of, all real numbers. So with range, we now take a look at this in terms of what's going on with the y-axis, what's going on up and down. And this, the shape of the graph actually is a little bit easier to see because it's very clear this is going up. It's very clear this is going down. It's going to hit all values along the way on the y-axis. So the range is sort of the same idea. Y is an element of the real numbers. It hits everything. So this is a full range, a full domain. I'm going to slide this guy up and we're going to take a look at one here that has a restriction for both the domain and the range. This curve, we can very clearly see, has a definitive starting point, and it is growing up and to the left. Okay. If we think about this in terms of the x-axis, it does not continue going past the number 4. It's everything on the left side of 4. So it is not every value in the real number set. It's only 4 and below. So we can write that by actually making the statement. I'll write it over here. X is all real numbers. And, oh, shook the camera. Then you have to say less than or equal to 4. Because that's where on the x-axis this curve kind of stops. It's only growing down below it. Now you can write that full statement. That is perfectly acceptable. You can write it out in English, but you can also use the notation, and you'll see how much shorter it is when I do that. X is all real numbers, but then I just say x is less than or equal to 4. So I prefer this just because it's a lot less writing, but it's really the same idea. If we now do this in terms of the y-axis, so now I'm looking at kind of the bottom in terms of the y-axis, I can see this sort of the same idea. It definitely has a starting and stopping point. That curve does not exist below 0 on the y-axis. So I would say y is all real numbers as long as y is greater than or equal to 0. It's only above 0. So this one has a little bit of a restriction on the domain and range, whereas we're only going to the left of 4 and we're only going above 0. As opposed to this, which is growing forever up and right, forever down and left, so it's going to hit everything on both axes. Let's take a look at a couple other ones. Maybe I'll slide this guy down here. We'll look at this with a W shape. This arrow here on the end means up and left. This is up and right. So when we think about this in terms of the x-axis, because it's going and left, because it's going and right, it's going to hit everything. So our domain on this function is x is all real numbers. And actually, that's it. I set up a comma as if I was going to do a qualifier, but there isn't. It goes forever to the left, forever to the right. It's the range that has a bit of a restriction. There is a definitive bottom of this curve. Like this one here, It doesn't go below the x-axis. My smallest number on the y-axis is 0. So y is all real numbers as long as y is greater than or equal to 0. I was going to take a look at the coordinates. The coordinates sometimes tend to be a little bit tricky until you really see what's going on. These are all just xy pairs. So this is -3, 1. This is -2, 0. This is 1, 4. This is 5, 1. And this is 2, -5. The domain by definition is the set of all the inputs. So here it's not a bunch of real numbers all connected. It's just those distinct values. Those are the only x values here on this set. So I just do x is exactly -3, -2, 1, 2, and 5. I just listed them least to greatest, but it's just that set of numbers. The domain would then, or the range, excuse me, would just then be the list of all the y values. So that is going to be y is, let's see, -5 is my smallest, 5, 0, 1, and 4. It's just all my y values. All right, last one I'll take a look at here. And of course, you can message me with any certain questions, specific questions, I should say. Okay, this one, that little arrow is really important. That is saying it's going forever down and right. And the other thing that's really important that we haven't talked much about are these open circles. That means it does not actually include those values there. It happens here as well. So if we look at this in terms of the domain, in terms of the left and right, the farthest the farthest this shape goes to the left is to -4. And because this is going down and right, it will continue going that way forever. So my domain is x is all real numbers, but greater than -4. And this time I don't do the or equal to because it doesn't include that. It's open at -4, which means I actually have to go beyond it in order to be in the domain. My range, it's going to be now the high down to the low on the y-axis. The high looks like it's up here at 1, and it doesn't include that value. So my range is y is all real numbers, but y is less than 1. And it does keep going forever because this is going down. Even though this is drawn lower, that arrow indicates that it is going to forever go down and right. Okay, so I hope those are helpful and you're able to complete the rest of these. You can certainly send me any more questions if you have some specific ones you were iffy on.